Hello and welcome to today's algebra lesson. This is a second video about solving a system of equations using the process of elimination or linear combination or addition. And here you see a system 3x plus 4y equals 13. And the second equation is negative 3x plus 6y equals 8, where it wouldn't be as simple to do it by substitution because none of the variables in either equation has a coefficient of 1. So you'd end up with a division in your expression for one of the variables, and carrying that around is kind of painful sometimes. But you can make this observation that, look, you have a 3x and you have a negative 3x. If you add those together, 3 and negative 3, you get 0. So, and if this had just been a negative x, I could have multiplied this whole equation by 3 and turned that to a negative 3x. But we'll just start with a simpler case here. So what I'm going to do is I'm going to add my two equations together. And remember, since the left of this is equal to the right of this, adding the lefts to the lefts and the rights to the rights is a valid process for keeping the equality in our equations. So when I do that, 3x minus 3x gives me no x's. I don't typically write that. So I've added the two equations. 4y plus 6y gives me 10y. 13 plus 8 gives me 21. So what I get here, I have to divide both sides. So I just solved, this is my new equation to solve, and that will answer half of my question. I get y equals 21 over 10. Now, to get x, I go back into either of these equations. I'll choose the top one. So the top one, I get 3x plus 4, and instead of y in the top equation, I am going to use my 21/10. And that's still equal to 13. So now what I see, what I observe in this equation is that I only have one letter, I only have one variable. So I can find a value for that variable. So when I do that, I get 3x plus 44 over 10 equals 13. So I subtract 44/10 from both sides. And I get 3x equals 13 will be 130, sorry, I wrote 103, 130 tenths minus 44 tenths, and 130 minus 44 will be 86 tenths. That's 3x. When I divide both sides by 3, I get 86 over 30, which reduces. 8 and 6 is 14, 1 and 4 is 5. That doesn't divide by 3, but they both divide by 2. So I get 43 over 15. So I get y is 21 over 10. X is 43 over 15. I can put these into either or both. I should be able to put them in both equations and see if I get a true statement to see if it's a solution. But that's another example of doing solution of a system by elimination. Thank you for joining. Email me your question.